Rational exponents. Now you must be guessing now what is a rational exponent. First, let's start off with this. This is not a rational exponent. This is a radical. We need to take this and turn it into a rational exponent. To do so, consider it like this. Since this is 16 to the fourth root to the power of 3. This root 4 can also be considered 16 to the power of a quarter. Following exponent law, which means that there's power inside the bracket and outside, you multiply the two together and combine them or simplify them. Doing that would make it 16 to the power of 3/4. This right here is considered a rational exponent. And if you put this into your calculator, you get 8. Now let's look at an example of rational exponents being multiplied and divided. Say you're given an equation like this. 16 to the power of a quarter divided by 16 to the power of a half multiplied by 16 to the power of 3/4. Now first we need to all make sure that the denominators are all the same. So the lowest common denominator for all of them would be 4. And to get that 1/2 to 4 would basically be multiplying the numerator and denominator by 2, making it 2/4. Now, following exponent law, when the number that's being affected by the exponent and all three are the same, which is true because they're all 16, you're basically, for dividing, you're subtracting, and when it's multiplication, it's addition. So technically, for the exponents, it's 1/4 minus 2/4 plus 3/4. If you add those all together, you get 16 2/4. Simplifying that, it becomes 16 to the power of a half. If you try to turn this into a radical, this basically becomes the square root of 16, which is 4. Either way, if you either put in your calculator 16 to the power of a half, or you put it to the square root of 16, you will always reach the same answer, because technically both of these are equal. Now, let me show you an example of where rational exponents come into real life examples as well as an example for a word problem. Let's say that a type of yeast cell duplicates every hour. So if there were 10 to start off with, after half an hour, it would become 20. After another half an hour, those 20 cells would duplicate and make it 40. Let's say if you start off with 50 cells, how many cells would there be after 1.5 hours have passed? So basically, putting this into an equation, the total amount is equal to I, which is the initial amount, which in this case will be 50. And since it's duplicating every hour, or every half hour, this becomes 2. T is the amount of time that has passed, which is 1.5 hours. And 0.5 is the half hour that passes every time it duplicates. So subbing it in, this becomes T is equal to 50 multiplied by 2 to 1.5 divided by 0.5. So simplifying that makes it 50 multiplied by 2 to the power of 3, and 2 to the power of 3 is 8, and 8 multiplied by 50 is 400. So to simplify this equation, I is the initial amount that you are going to start off with. This right here is the amount so if it triples, this 2 will become 3, or if it quadruples, this 2 will become 4. T is the amount of time that has passed, and D is the amount of time that it takes for it to double, triple, quadruple, the total amount of time that it would take for one of these cycles to happen.